Okay, geometry review part 1. We'll go through about 31. Okay, number 1 starts off kind of simple. If shape BCDE is congruent to OPQR, then D is congruent. Basically, you don't see the shape. You just got to follow the order of the letters. Okay, so number 1, order of letters. Okay, so as you can see here, DE. So here's DE. Well, what two letters line up like that in the other polygon or shape? It'd be QR. Okay, so that's why D is the correct answer. Number 2, triangle MNO is congruent to triangle PQR. Which of the following can you not conclude as being true? Follow the order of the letters. So MN, PQ, not PR. Okay, so right there, A, you know, is not being true. Number 3. Okay, we got these two triangles here. Angle ABC is congruent to which one? So let's go find what ABC is. B is the middle letter, so that's called your vertex. So here's ABC, this angle here. And as you can see, they've labeled the angles by little lines from. This has no line, this is 2, this is 3. That's only a single little arch. So go find the single arch in the other one. It's right here. The vertex in is N, so it's MNP. You can also flip the first and third letter. You got to keep the middle one the same. It's your vertex. Okay, number 4. Number 4 is kind of different. Which congruent statement does not necessarily describe the triangle shown if triangle DEF is congruent to triangle FGH? Okay, now basically, again, follow the order. So if it says not describing it, so which one of these is out of whack, out of order? So here they go, EDF. So let's look at this, EDF. So EDF, that's congruent to GFH. That says it's congruent. We don't want to circle that one because that is describing the triangle. Not necessarily. So FDE. FDE. That'd be HFG. It'd have to be in that order. But that's out of order, okay? So we know letter B is the correct answer. If you look at this, EFD. So EFD, it's going to be GHF, which it is. FED, HGF, it is, okay? All right, so that is how we know that one. Okay, number 5. Given that triangle QRS is congruent to triangle TUV, we know that QS equals 3 times V plus 2, and TV is equal to 7 times V minus 6. Find the actual length of side QS and TV. Okay, now QS, TV, those go in order. QS first third, TV first third, so they have to be equal. Those sides do. So what I do is I set those two expressions equal to each other. So 3V plus 2 equals 7V minus 6. Now we got to solve for V, find out what that equals. Okay, so we want to get the V's on the same side. So minus 7V minus 7V, and that's going to give me negative 4V plus 2 equals negative 6. Then we minus 2, and negative 4V equals negative 8. And then we divide both sides by negative 4. And V is 2, okay? But that's not your answer, okay? They want you to call it your answer. They're trying to trick you. You want to find the actual side length of both of them. All I found so far is the letter V. Okay, so what I do is I go back into these expressions and put 2 in for V. So 3 times 2 plus 2. And then 7 times 2 minus 6. Okay, so 3 times 2 is 6, plus 2 is 8. 7 times 2 is 14, minus 6 is 8. 8 equals 8. So each of those sides is a side length of 8, which is why C is the answer. So when you solve for the variable, that's not your answer. You got to go plug it back in to your equation and see what each side's equal to. Number 6 is the same concept. Triangle ABC is congruent to triangle PQR. The measure of angle B equals 3 times V plus 4. And the measure of angle Q is 8 times V minus 6. You need to find the actual measurements of B and Q. So I'm going to solve for V and then plug them into these and times and add and times and subtract. So again, we're talking about B and Q are in the same place, so we know those angles are congruent. They have to be equal. So 3V plus 4 equals 8V minus 6. So I minus 8V minus 8V. That's negative 5V plus 4, negative 6, minus 4 minus 4. So negative 5V and then negative 10. Then we divide, so negative 5 times V is negative 10. V is going to equal 2. But again, you don't want to say that that's the answer. It's not even one of the options. So I need to go back up here and put 2 in for the V's. So 3 times 2 plus 4, 8 times 2 minus 6. Okay, that's 6, and then plus 4 is 10. And then that's 16 minus 6 is 10. So that is why C is the answer, because each side is 10. Okay, number 7. In the paper airplane, ABCD is congruent to EFGH. Okay, so look at ABCD. It's a quadrilateral. There's 4 sides. EFGH, that's a quadrilateral. They're congruent. Everything's congruent. The sides are the same. The angles are the same of those 2 shapes. The measure of angle B equals a measure of angle BCD, which is 90. So what I've done is I went into B and put 90. That's a 90 I wrote right there. You can't see it. Cameras doesn't pick up that small of writing. So I put 90. And then BCD is also 90. So BCD, I've also put a 90 in that one. The measure of angle BAD is 131 degrees. So BAD, and I put 131. It says find the measure of angle GHE. So GHE is on the other quadrilateral. So GHE, and it's this angle here. Well, if I knew how much that angle was, this angle is the same because they're congruent. D and H are congruent angles. So I'm obviously going to have to find D because that's where I know all the measurements, and then I'll know H. Now, what you need to know is that a quadrilateral, all the angles have to add up to 360 degrees. And I know what 3 of them are, 90, 90, 131. So I need to subtract those in order to find the remaining angle, because I know they all add up. So 360 minus 90 minus 90 minus 131 is 49, so 49 degrees. So I'm going to put a 49 there, and then that one's also 49 because they're congruent angles. So that's why B has been labeled, chosen as the correct answer. Okay, number 8, the 2 triangles are congruent as suggested by their appearance. Find the value of C. The diagrams are not drawn as when they say appearance, you just kind of match them up, okay? So 3 would go as C. So that's your answer is 3, C. by their appearance means they look the same. So that course G corresponds to 5, 38 degrees corresponds to D degrees, F degrees corresponds to 52, and so forth. Okay, number 9, use the information given in the diagram. Tell why segment MN is congruent to segment PO. And we got to tell why angle NOM is congruent to angle PMO. Okay, so first off, let's look at this. They are indeed congruent, so MNPO, go find those sides. So MNPO. As you can see, each segment has those 2 little tick marks through it. 1, 2, 1, 2. So when they give us those tick marks, that is given information. Angle NOM, so NOM, it'd be this angle inside here where my pencil's at. And PMO. So PMO, that's where my pencil's at. So those are the 2 angles, and they both have one single arc, okay? So that's given information. Okay, so given and given is the answer. Now, the ones with 2 arcs, those are congruent. The ones with 1 arc, those are congruent. When they put those arcs or those tick marks, that means it's given. Okay, number 10. Justify the last 2 steps of the proofs. Gotta love the proofs. Given that segment RS is congruent to segment UT and segment RT is congruent to US, prove that triangle RST is congruent to triangle UTS. Okay, so RST, UTS, top triangle, bottom. So they told me RS is congruent to UT. So I took RS, UT, and put 1 single tick mark through that side because those are congruent. RT and US, I went to RT and US and put 2 through that. Okay, now you're going to add a side. They share the side. This side covers both triangles, this side here in the middle. It's called the reflexive property. I'm going to put 3 tick marks there. Okay, now one thing you're going to have to know is your triangle postulates. Here they are. SSS, ASA, AAS, or SAA. Doesn't matter. SAS is probably the most common. I think if there's any more, have them written down somewhere. No, that's it, okay? Those are the 4. You can't spell ass either, okay? ASS is not a postulate, and neither's SSA. You can't spell ass, you can't spell it backwards, okay? All right, so they gave us those 2 things. Now, what tells me that ST and TS? Well, when they tell you that the same side's equal, it's kind of common sense, but that's known as the reflexive property. Or if they just give you the same 2 letters, just order switched. And then how was I able to finally determine that those were the same? Well, I don't know anything about the angles. Instead, they have 3 congruent sides. Here, 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 and in the middle. Therefore, it's your SSS postulate, which is why letter C is your correct answer. Okay. Number 11. This is an easy one. Name the angle included by sides PN and MN. So here's PN. Here's MN. Where do they meet? Right here. Okay. So that's angle N, which is why letter A is the answer. Number 12. What other information do you need in order to prove the triangle is congruent using the SAS congruence postulate? Okay, SAS, side angle side. So you need two sides and then an angle between the sides to know that they're congruent. Okay, so we pretty much know those sides are congruent, and they share a side, so I'm going to put 2 there. So we're at 2 sides that we know are congruent, but now we got to find an angle in the middle. And the angle in the middle is these right here, okay? They the angle here, the angle here. They meet at C, so C is the vertex. So we can forget about A, because here A is the vertex. I'm looking for C as the vertex. Again, B and D, nope. Remember, sides, side, side, and then side. So I need an angle between those sides, right here and here. That's vertex C. Well, that doesn't do any good because that's 2 sides. Now the answer is B, because if AC is perpendicular to BD, then we know these are both right angles, because that's the definition of perpendicular lines. They form a right angle. So side angle side, side angle side. Okay, so that is why B is the correct answer. Okay, number 13. State whether triangle ABC and triangle AED are congruent. Justify your answer. So know where your triangles, ABC, AED. Okay, so there's my congruent angles. Here's one pair of congruent sides, and here's the second pair of congruent sides. So it goes angle, side, angle. Well, I'm sorry, but angle, side, angle spells a cuss word, so that's why you have part D. Okay, you go side to angle, or SS, or SSA, ASS, SSA. Can't spell ass, can't spell it backwards. Okay, number 14. Which of the triangles are congruent by angle, side, angle? So you need 2 congruent angles and then a side in between them. Well, this only shows 1 congruent angle, so we can just 2 congruent sides, but 1 congruent angle. I need 2, so we can forget about that. Now let's look at here. Do I have a congruent angle? Yeah, I do, here and here. Do I have another congruent angle? I do, here to here. Okay. So there's one pair and there's another. Now between the congruent angles I have 2 tick marks, and between the congruent angles I have 2 tick marks. So that's why we have that. Okay, angle, side, angle, angle, side, angle, ASA. So it's, what is it, HGF and ABC. So it is letter B. Okay, B is the right answer, not A. Okay, number 15. Which 2 triangles are congruent by the ASA? So segment MR bisects QO. So here's the significance of so here's MR, QO. So MR runs right through the middle. A bisecting side means that this and this are congruent. So put 1 tick mark, 1 tick mark. We also know that that angle MQP is congruent to ROP. So MQP, make an arch, ROP, make an arch. Now, there's also the issue of vertical angles, okay? When we have these 2 angles kind of kissing and making out, I know it sounds weird, but that's how I think of it, they're congruent, okay? So that'd be a second set of congruent angles, so I make 2 tick marks there, okay? So what do I have? I have an angle, a side, and an angle, okay? So ASA. So we know that this triangle and this triangle are congruent right here, Okay, you just got to figure out the names. MQP and OPR, okay, or MPQ, RPO. So that's why part B is the answer, okay? So you got to label your given information with these proofs. When they give you sides, mark them with the tick marks. When they give you angles, put the arches, double arch them, triple arch them. Okay, which pair of triangles is congruent by the ASA postulate? Okay, so angle, side, angle, but that's angle, angle, side. Okay, it's got to be two angles with a side between them, so it's not that one. Side, angle, side, that doesn't work. It's got to be angle, side, angle. Side, angle, side, that doesn't work. Angle, side, angle, booyah, it's D. Okay, number 17. What is a missing reason in the two-column proof? Okay. I'm going to erase what I drew there. Okay. MO bisects PMN. So what you have to do is go to PMN. It's this big angle here, PMN, but this line segment bisects it. So that means those are congruent angles. And line segment OM bisects POM. Okay, so here's POM. Those are congruent angles, but you need to double arch them because you've already used the single arch. Okay? And another thing, if you look, both triangles share a common side right here. So mark that. So angle, side, angle, but now you have to look. Okay? The bisect's given. Definition of angle bisector means that those two right there are congruent. MO, that's always a reflexive property. Makes that a congruent side. OM, PON, again, that makes those congruent. The bisector does. And at the end, you just got to name the postulate. It's angle, side, angle. Okay, so that's letter A. Number 18. Name the theorem or postulate that lets you immediately conclude that triangle ABC is congruent to triangle CBD. Okay, so ABD. Again, this is what's given information. So it looks like we got our angles. The right angle, and then these angles are congruent, and they share a common side, okay? So it goes angle, angle, side. So angle, angle, side, letter A is that. Okay. Okay, number 19. Yeah, you got to know all the postulates. Write them down, memorize them, write them down on your paper. Remember, you just can't spell this. Also, another word, you can't spell ass, and you can't have three A's. I know that sounds weird if you think, well, if all three angles are congruent, the triangles would be congruent. They're not. Okay, all sides make it congruent, but not all the angles. Okay, next one. Given that A is congruent to D, those are angles, so arch, single arch, and C is congruent to F, so double arch those. Or no, double arch them, sorry. Okay. Which additional statement does not allow you to conclude that triangle ABC is congruent to DEF? Now, you see angle, angle. None of the sides are congruent, okay? Now, a lot of people will think, because BC and EF, okay, well, if BC and EF, I'd have side, angle, angle, or angle, angle, side. That's true. B and E, okay, if those angles were congruent, then we'd have three pairs of congruent things, but that does not make them the same. Just because all the angles are the same does not mean it is. Okay, so that's why letter B. Okay, number 20. And I've written on this because when I was figuring out how to do them myself, we had them, that's why I have to erase. Can you use the side angle side postulate, the angle side theorem, or prove both to prove the triangles are congruent? So let's look at here. Those angles, they don't share a common side, but they are kissing angles. Okay, those are vertical angles, what they're called. So I need to use the double arch because you've already used single. Okay, so what do we have? We have a angle, an angle, and a side. Okay, again, angle, angle, side. So that's why part C is your answer. Again, I got two angles and a side. Angle, angle, side. What else must you know to prove the triangles congruent by the ASA theorem and by the SAS theorem? So let's start with ASA. So those are congruent angles. They also have a similar side. So right now I have one pair of congruent angles and then a side. Okay, so let's talk about the ASA. Well, then I'd need another set of congruent angles. Okay, so ASA, angle here, side here. So these two common angles are congruent right here. Well, again, we want angle, side angle, so I need a third angle. Well, if I knew that this was congruent to this, then I'd be good. I'd have angle, side angle, angle, side angle. Okay, so I'd have to know that BAC is congruent to DCA. So BAC... Where's BAC? So ACDC. Actually, hold on a second. I don't like how I'm explaining this. Let's just start this process over. Okay. So ACD congruent to CAB. So ACD. ACD's right there. CAB. CAB. Okay, it already gave me that congruency because there's already a mark there. So that doesn't help me. Okay, B, ACD, and CAB. So we'll swing the double arcs there. Okay, if that was true, I would have angle, side angle. Okay. Now, but there's two of those answers. We can eliminate these by process of elimination, okay? Because both these statements, ACD and CAB, okay? If those are congruent, you're going to have two angles and then a side in between them. So that's why angle, side angle works. Now we need to erase the paper, and we need to look at the second thing we need, the SAS. So side AD is congruent to side BC. So AD is a side. So there's my first congruent. Two tick marks. And BC is a side. Okay. Well, that gives me a side, an angle, and a side. Again, a side, an angle, and a side. And that's what SAS is. So it's part B. See, if you look at the other answer, D, AD, and AC, AD, AC, well, that's not going to help me because that's the same triangle, okay? AD and AC, that's the same triangle. It has to be different sides, different triangle. That one's kind of a complicated one. I probably didn't do a great job explaining it. Okay, number 21, 2. Based on the given information, what can you conclude and why? Okay, so angle H is congruent to angle L. So we want to tick mark those. And side HJ is congruent to side JL. So HJ mark it, JL, mark it. Now, they don't share a common side, but again, we got those kissing angles, so that's going to be 2 kind of fitted in there. And what I have is an angle, a side, and an angle. Okay, so angle, side, angle, so it got to be quite obviously ASA, but there's 2 ASAs, so we can forget about those 2. So now I have to look, HIJ, so we know that H and L are congruent, so H and L have to be in the same place. So H and L are in the same place here. H and L are not in the same order here. So when they give you 2 answers like that and all that's different is the letters are jumbled, your congruent angles have to be in the same order. So we can eliminate that, and that's why A is the answer. Okay, number 23. From the information in this diagram here, can you prove that triangle FDG is congruent to triangle FDE, and then explain? Okay. So you can see the 3 you got congruent angles here, here, and here. But AAA is not a theorem, okay? Is there a side somewhere? Well, yeah, they share this common side, okay? So look at the side, and then you got angle, side, angle. Angle, side, angle. So it's the ASA theorem, which is letter A. Okay, so there's that side, angle, angle, side, angle. Okay, 24, you're going to have to draw a picture. I'll do it on my scratch paper here. RST are the vertices of one triangle, so I'm going to just make a triangle about like that, and RST. EFD are the vertices of another triangle, so EFD, just draw them. R is 60 degrees, so I'm going to put a 60. Angle S is 80 degrees. So I could find T too, because I know they add up to 180. So 180 minus 80 minus 60. Okay, and that's 40. So put your 40 right there. Now they also tell me that F is 60. And the measure of angle D is 40. So 100 minus 60, 180 I should say, minus 60 minus 40, that's 80. RS equals 4, that's side, and EF equals 4. Are the 2 angles congruent? If yes, explain and tell which segment is congruent to RT. Okay. Okay, so let's look at here. Well, the common side's 4, okay? So, boom, mark it. 60 and 60, that's good. So, angle, side, and then 80 and 80. So, boom, 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 boom. So, we got angle, side, angle. So, it's SAS, or no, sorry, angle, side, angle. So that's pretty much your answer right there. It says what side's congruent to RT. So if you look at RT, that's between the 60 and the 40 degree angles. So 60 and 40 would be FD or DF. Okay, one of those 2. Okay, number 25. Okay, angle Q is congruent to angle T, so here's Q and here's T, just single arc those. Segment QR is congruent to TR, so QR and TR. Okay, now, so I know I have a congruent set of sides and angles, and they don't share a common side, but they got the kissing angles. They're called vertical angles. Okay, swing 2 arcs on that one. Okay, so we had the given information. The vertical angles are congruent. So why are those two triangles congruent? Okay. Well, we got angle, side, angle. Again, angle, side, angle. So that's ASA. And then PR, and then they give me, say, line segment PR and SR are congruent. Well, look at PR, look at SR. Those are what we call, once we know the triangles are congruent, and then I say, well, these sides or these angles have to be congruent, that's called the corresponding parts theorem. So it's ASA and corresponding parts, and that's why D is the answer, not C. Okay, when we know the triangles are congruent, we just pick parts to say they're congruent. That's called corresponding parts. Okay, 26. Supply the reasons missing from the proof below. Okay, AB is congruent to AC. They give us that and ticked it for us. BAD is congruent to CAD. And we have to prove that AD bisects BC. Okay. First off, given. AD, yeah, it's true. It's reflexive property. How do I know that angle BA triangles are congruent? Well, they share a common side, okay, but we've already used the one tick mark. So SAS, okay. So it's the SAS theorem. And then we can forget about the rest, these two. Okay. BD is congruent to CD. Because if AD bisects BC, that's like the definition of a segment BD is congruent to CD. And they say AD bisects BC. Oh, yeah. If segment AD, those are congruent as well. Okay. So BD, CD again. Once we've identified triangles as being congruent, entire triangles, we can pick corresponding parts, BD and CD. So it's the corresponding parts. It wouldn't be a reflexive property. Reflexive property is when they just tell you two letters and then switch them. Like AB equals BA. That's why it's D. Again, so after that statement, we can go through there. Okay, what's the value of X? Okay. Well, here's the deal. You know you have 180, and then you know you got 38, so you can subtract that. So 180 minus 38 is 142 degrees. Now, these are both X. So I have 142 degrees that's got to be split equally among the two angles. So if we're splitting it equally amongst two, we divide by 2, and that gives me 71. Okay, I did not like how I explained this one. I want to go back here. Sorry. I was kind of bumbling through it. Okay, so given info is already labeled for us, and then we got the common side. So by the SAS postulate, I know that the triangles are congruent. Then we can pick parts, so BD and CD. Those are in the same order, so that's called the corresponding parts theorem. So SAS, corresponding parts. When they already say the triangles are congruent, and then they pick parts of the triangles and say they're congruent, it's corresponding parts. Okay, what's the value of X? So we didn't know that. Now you got to know your isosceles triangle theorem. Isosceles triangle means two sides are the same as given. If those sides are the same, these angles are the same. So if that's 56, so is that. So the value of X, I know the angles add up to 180. I minus 56, minus 56 again because we have two 56s. And the result is 68. It's is why you have A. That's called your isosceles triangle. With an isosceles, these are the same, and then those are congruent as well. Okay, what's the value of x? Again, it's another isosceles triangle. I know that those sides are the same, so then the angles that go opposite those sides are the same. So if those are the same, and we know that's x, then across from here has to be another x. So I take 180 minus 93.5. (86.5), and then that 86.5 degrees is split equally amongst the two angles. So if it's split equally, you divide it by 2. That's 43.25. That's letter B. Okay, here's a fun one. By that I mean not. Definitely gonna have to use my scratch paper. Okay, I got to determine the value of x. RS and ST are congruent. So RS, ST, mark those. So we know that those, by that, I know that these angles here are congruent. The measure of RST is 7x minus 54. So RST, I'm going to put a little 7x minus 54. And STU is 8x. So STU 8x. Now, there's something you need to know. It's called supplementary angles. See this angle and this angle? If you took this bisector of that segment out of there, you'd have a straight line. Well, a straight line adds up to 180 degrees. So even though I don't know the degrees of that, I know it's this angle is 180 minus that. Okay, it's supplementary angles. So right here, this angle inside, I just take 8x, subtract it from 180. My battery's about to go dead. I gotta